Hi, in this video I'm going to have a brief introduction to the fundamental trigonometric identity. First, let's talk about what an identity is. An identity is a mathematical statement that's going to connect two expressions with an equal sign, and it's going to have to be true for all the values of its variable that fall in the domain of both expressions. So one thing that you will probably have seen before, this is expanding or factoring depending on which way you're going to look at, but that's an example of an identity because these two sides are going to equal each other. What makes this a little bit more complex? We should recognize that in the first expression, I'm sorry, the expression that's on the left, x cannot equal 3. So if x cannot equal 3, what we can do next is say that, well, I know this can be factored as x minus 3 times x plus 3 divided by x minus 3, and when you divide those out you're going to get x minus 3 equals x, I didn't cancel the right thing, x plus 3 equals x plus 3, right? And that's a true statement, but that's not the focus here. We're going to talk about trigonometric identities. So some of the identities that you should know are reciprocal identities. I'm sure you've been doing trigonometry for a little bit already and you should be familiar with those things. So sine is the reciprocal of cosecant, tangent is the reciprocal of cotangent, secant is the reciprocal of cosine, cosine is the reciprocal of secant, cotangent is the reciprocal of tangent, and cosecant is the reciprocal of sine. And you probably also have seen quotient identities. Tangent theta is sine theta divided by cosine theta, and cotangent theta is cosine theta divided by sine theta. But let's talk about Pythagorean identities. So there is one very important one. So if I'm in the unit circle and I draw this, then we have our x and y coordinates here, which in the unit circle you know correspond to x corresponds to cosine x and y corresponds to sine x, correct? So we have some angle theta here, but in this triangle, since this is 1, this is the unit circle, so this length here is x and this length here is y. So it's a right triangle, and therefore I can use the Pythagorean theorem. So I can write that x squared plus y squared equals 1 squared. So x squared is cosine squared x. Y is sine x, so it's sine squared x equals 1. We're going to have sine squared x plus cosine squared x equals 1. These two things are exactly the same, but we usually see it in this format. So that's what we know is one of the fundamental trigonometric identities. It's always going to be true, no matter what the angle is. Okay? Based on that, here's what we can do. If I take this expression and divide everything by sine squared x, theta, what am I going to get? Sine squared theta divided by sine squared theta is 1. Cosine squared theta divided by sine squared theta is going to be cotangent squared, and 1 divided by sine squared theta is cosecant squared theta. That's another identity that is commonly used. If I take this expression, I divide both sides by cosine squared x, this theta. Keep saying x, but it's theta in this case. Then what am I getting? Sine squared theta divided by cosine squared theta is tangent squared theta. Cosine squared divided by cosine squared is 1. 1 divided by cosine squared theta is secant squared theta. Okay, I hope this was helpful.